Okay, yeah. Welcome to Let's Get to the Marks. I'm all over the ship shop. Right. Let's go. We're going to look at a nitrogen cycle today. So, yeah, lovely jubbly. There we go. Um, yeah, so this was requested on the little whatever text poll. Nitrogen cycle. So we're going to go through a little bit on the old nitrogen cycle. So I want to talk about it, then we'll do some questions on it. We could go on PMT, Physics and Maths Tutor, Wiki website, have a look at some questions. We'll have a little look anyway. Right, let's get into it. So, what do we need to know about the nitrogen cycle? So I'm just going to go through the basics and then we do some questions. So if you're new, make sure you subscribe. Make sure you hit the like as well if you find the A-level lessons helpful. I normally would be doing this on Thursday, but had a bit of a mini emergency in the week, so had to reschedule last minute. So what's the first thing? We've got nitrogen in the air. Nitrogen, everyone knows the formula for nitrogen, N2. So diatomic molecule, two nitrogen molecules joined by a triple bond. Very strong bond, obviously, as it's a triple bond. Now, nitrogen, how does it get from the air into living things? Do we know the name of the process by which nitrogen goes from the air into living organisms? So how does it get from the abiotic, the non-living, into the biotic? Hopefully you know the answer. It does this through a process called nitrogen fixation. And nitrogen fixation can be done by two types of bacteria. You've got, let's hope, I didn't even do a mic check, but there we go. What are we going to do? So, two types of bacteria. You've got free living, they're free living bacteria, and they live in the soil and they're free. Azobacter is an example of one. And then you've got other ones, an example is Rhizobium, that live in a symbiotic relationship or mutualistic relationship in the root nodules of leguminous plants. Now, legumes, I think it's French, well, leguminous plants, peas, those kind of things, are very good at fixing nitrogen in their roots. And so there's a type of bacteria called nitrogen fixing bacteria. They live in the root nodules of those plants, or they can just be free living in the soil. I need glasses. Glasses. Did I get glasses? I don't think these glasses are decent at all. Okay. Oh, and did I charge my phone? No, I didn't. Cause at lastminute.com. Denitrification is a process, but we're looking at nitrogen fixation for how nitrogen gets from the air into living things. Is nitrogen fixation. So oh my days, let's look at that process first of all. Oh my God, what is going on there? My phone's giving me the temperature. I don't want a temperature. Right. So what we got here, nitrogen fixation. This is a process. What do you have to know for A-level biology? Do you need to know the names of specific bacteria and species? You have to check your exam board for that. Most exam boards, I know for AQA, I don't think you have to specifically know the names. They'll throw those names about and expect you to apply your knowledge. So nitrogen fixation converts nitrogen into ammonia. And during this process, it can happen in a couple of different ways. So this is one way, and leguminous plants such as pea plants have these nodules. Check out these round balls on the roots. These are nodules. That is where bacteria live. And this is an example of some bacteria that do this. Rhizobium bacteria. They live in these root nodules and they take N2 gas from the air and they turn it into ammonia. Now, hopefully you know the formulas of these things. So nitrogen has the formula. Oh my gosh, why am I writing in that? Let's get rid of that. Let's go for a darker color that you can actually see on the board. That'd be helpful, wouldn't it? So nitrogen goes diatomic molecule like that, and it turns into ammonia, okay, in the soil. It's not quite ready in the form of NH3 to be taken in by plants and used to make amino acids and proteins. So we need to do a little thing to this nitrogen before it can be taken into plants and used as proteins. So anyone know what's got to happen to the NH3 before it can be used by plants? They can't really just absorb ammonia that well into their roots. There's a better form of nitrogen that they can take in to their roots. So not sure if you know the form that they do it in, but it's actually as nitrates, which has the formula NO3. So that's the soluble form of nitrogen that plants most like to absorb by active transport, facilitated diffusion through their into their root hair cells. Now, you have to understand, and you maybe have to apply your knowledge as to why this is a mutualistic relationship. So what is it that the bacteria get out of living in the roots of the plant? So the bacteria live here. Well, the bacteria get free carbohydrates. The plant is a specialist at doing photosynthesis and forming complex organic molecules like starch, amylopectin, amylose. So those rhizobiome can get hold of some complex carbohydrates or some simple carbohydrates like glucose, etc. They can get those from the plant, so they don't have to do photosynthesis to do that, and they don't have to go and be a heterotroph and consume things, engulf things to get their complex carbs. They can get those from the plant. Now, what do they give to the plant back in return? They give to the plant back in return, they take that nitrogen from the air and turn it into ammonia. So they do the first step in giving the plant nitrates. Okay, so it's a mutualistic relationship or symbiotic relationship. We could call them symbiotes. They live together harmoniously, sort of thing. So that's one way of nitrogen fixing. You do need to know that there are free living nitrogen fixing bacteria that don't have a mutualistic relationship, and those nitrogen fixing bacteria called azobacter, that's one of them, they just live free in the soil, and they can take nitrogen directly from the air and turn it straight into NH3 ammonia. Okay, and that is obviously a super important process as well. Any questions about nitrogen fixation? Has anyone got any questions? Feel free to ask if you have any questions about nitrogen fixation. Don't forget to hit the like if it's helpful. So just put in the chat any questions if you have any about nitrogen fixation. You might have heard of some other ways that nitrogen can be fixed into the soil. You might have heard of other ways. Let me zing this on here. Okay. You got to subscribe to the channel if you want to make a message in the chat or whatever. Right. Zinging on. So another way that nitrogen can be fixed into the soil is through lightning. So lightning, literally 30,000 Kelvin, super high temperatures, a lot of volts, that can split the nitrogen triple bond. Remember I talked about the triple bond. Nitrogen has this really strong triple bond like this, and this can be broken by the lightning, and once it's just a couple of nitrogen atoms, the oxygen bond between oxygen, O2, can be split as well, and there's the energy and pressure created to force N and O together to make nitrogen monoxide, nitrogen dioxide, nitrogen trioxide. They dissolve in rainwater, dissolve in water on the ground from the rain when it's rained, and they become nitric acid, and then they turn into nitrates. So even if there were no plants on the earth, or there were no nitrogen fixing bacteria, some nitrogen would still get fixed. So imagine all the nitrogen fixing bacteria were killed, some nitrogen would still get fixed. About 5% of all the nitrogen in the air that becomes fixed in the soil is fixed by lightning. 95% is done by the bacteria, so it would have a huge impact if there were no bacteria in the soil. Okay, moving on. So that's just a summary of what we've covered so far. So we've got nitrogen fixation by rhizobiome bacteria. They're the ones in the mutualistic relationship in the root nodules. Turn nitrogen gas into NH3, which is ammonia. Lovely jubbly. Now, it's then turned into NH4 plus, which is ammonium. But in the exam, you can often say ammonia or ammonium, kind of the same starting point. What we're going to get to next, the process of making ammonia into ammonium ions, or forming ammonia, either NH3 or NH4 plus, is known as ammonification. And this is when dead matter, like your waste, poo, we don't say poo and we say urine and feces, but this is when urine and feces from animals or dead plants, the leaves of plants, decay with decomposers, and they are turned into ammonia. So that's where we get the ammonia from. It's from ammonification. But nitrogen fixation, which we already discussed in the root nodules, also makes ammonia. So there's two pathways to make ammonia: ammonification, and then nitrogen fixation can make ammonia. Okay, let's move on. So we're going to whip through the content, and then we can go through some exam questions. I can't really see with these glasses. Don't know why I picked these glasses. Never mind. Right, so here's our little cow having a munch, eating some plant material, and then passing out some waste, or the animal dies like this dead bird, or leaves fall off a tree, plants die, and this organic waste is decomposed into NH3 and then into NH4 plus, and this is known as ammonification. But we can go down that route as well. The nitrogen can be fixed by nitrogen fixing bacteria, and you can get to ammonia that way. But it can be free living azobacter. I haven't included those on here. I could include those, but they would be free living azobacter in the soil, can also do nitrogen fixation. Anywho, we're now at the point of having ammonia. We're not ready to go back into plants and be turned into amino acids. So the next step is called nitrification. Now nitrification turns NH3 ammonia into NO2, which is nitrites, and they have a little minus sign. What does that tell us? They have a negative charge, and those nitrites can be turned into nitrates, NO3. Both of these steps are called nitrification. Now if you look closely, what has happened when it goes from NH3 or NH4 plus, either of those two molecules, to NO2, what has it gained? What's been added to the nitrogen? Anyone in the chat, if you want to get a boom, what's happened to the nitrogen in the NH3 or NH4 when it's been nitrified to NO2? An element has been added to it. The hydrogen's been removed. Oxygen's been added. Nitrification is known as oxidation. So this nitrification process involves oxidation. It requires oxygen. So that's an important thing you have to understand for the application questions, those AO2 questions that come about in A-level biology, where you have to apply your knowledge, not just memorize, but apply it. So this requires oxygen to happen, and you can kind of see that because it's gone from having no oxygen to having oxygen. And then even if we look at it here, going from NO2 minus, it's gone to NO3. And you might remember from chemistry, oxidation is a loss of electrons, oil rig. You might remember that mnemonic from doing your GCSE chemistry even, oil rig. Oxidation is losing electrons. So it's got this negative charge here when it's NO2 minus, then it goes to NO3 and it no longer has a negative charge. So it's been oxidized. It's lost that negative charge, which is an electron. So both these steps in nitrification are oxidation reactions. And so and they're two different bacterias do this. So let's have a little look at what we got going down. Right. So the two steps of nitrification. In the first step, nitrosomonas, don't know if I spelled that right, that might be an O supposed to be there, never mind. Nitrosomonas bacteria turn ammonium ions into nitrites. That's nitrates. So we're going like, in this situation, we're saying NH4 plus. That's how you write an ammonium ion, or that's the chemical formula for an ammonium ion. And then nitrates is NO2, normally with a minus. Okay, having a sneezing attack. So we're going from that to that. That's oxidation, and it's done by nitrosomonas. Very important that you know this requires oxygen. Very important for those application questions that you get in A-level biology, that you realize this is oxidation. And both are oxidation, both nitrification reactions require oxygen. And these bacteria also are aerobes. That means they respire aerobically. And that is also important because you're going to get situations where we talk about there being a lack of oxygen, and you have to understand which of the bacteria in the nitrogen cycle could be affected by a lack of oxygen. So nitrobacter turn nitrites into nitrates. So these bad boys, they're another species. Do you have to know these names off by heart? You can just call them nitrifying bacteria. You definitely have to know that off by heart. And they're going to turn the NO2 minus into NO3 like that. So again, it loses an electron, gains an oxygen. This is nitrifying bacteria. You definitely have to know they're called nitrifying bacteria. You'd have to check your spec whether you need to know the specific names. Nitrosomonas and Nitrobacter are just like species, different species of bacteria, different groups of families of bacteria. So the nitrates are then absorbed by facilitated diffusion. Really, mainly you have to focus that they're absorbed by active transport. For your AO2, those root hair cells are going to need lots of mitochondria to do aerobic respiration to absorb these these nitrates into their root hair cells and then to go on and make amino acids. So we can think now what would happen if there was a lack of oxygen in the soil. It's going to affect this nitrification process. This isn't going to happen. We're not going to make nitrates. It's also going to affect the root hair cells being able to do aerobic respiration, active transport, what I'm waffling about. They won't have the oxygen to do the aerobic respiration to produce the ATP that they need to power the active transport of the absorption of nitrate ions. So you're going to have big impacts on plant growth and their ability to make amino acids and things like that. Right. Zinging on. There is another process. So we've got nitrogen fixation, ammonification, and then nitrification down here. And then, this is a real crusty diagram, obviously. And then we have denitrification. Denitrification is basically reforming nitrogen in the air, and this is done by a type of bacteria called denitrifying bacteria. So, yep, let's go. What have we got? What have we got? What have we got? You don't need to know any specific names of denitrifying bacteria. There are loads of different names. Oh my gosh, I can't even think of one off the top of my head. But there's loads of different names of denitrifying bacteria. You just need to know that the bacteria that return nitrogen to the non-living part, the abiotic part of the atmosphere, is they're known as denitrifying bacteria, but there are tons of different examples. What denitrification is doing, these bacteria use nitrates for anaerobic respiration in low oxygen conditions. Some of them can also do aerobic respiration when there's oxygen about, and they're going to do anaerobic respiration in low oxygen conditions and form nitrogen. Okay, we're going to get on and do some questions in a second because it's basically all about wrapped up. Hold on. Yeah. Whatever. That's about it. It's kind of cool. Right. Plants can then take in nitrates by active transport. Didn't write anything there. Let's have a little go at some questions and see if we can apply those. Right. What I want to do is fix up my charger. Any questions about the nitrogen cycle, first of all? Has anybody got any questions they want to ask about the nitrogen cycle? A level. A level. Galafias, A level. You do this in A2 in most exam boards. So, oh, what has Mathilde said? An electron has been gained. What's that? Is that during nitrogen? Oh, question mark. Is that during? Oh, I've probably mashed up something on this. Yes, electrons are gained. Let's see. NO2 minus. What have I shown here? So electrons will be gained when it goes from ammonia to nitrite, and then from nitrate to nitrate. I should put a minus there as well. My mistake. So what if you know how to do oxidation states? If you're a chemist, then you can see the oxidation with the gain of the loss of electrons. Sorry. So electrons are lost, oil rig, oxidation is loss of electrons. So if you're a chemist, you'll be able to tell that this has lost electrons when you go from NO2 minus to NO3 minus. But if you're a biologist, you can just think about that it has gained oxygen. So if it's gained oxygen, it's been oxidized, and you can kind of see that because it's gone from NH4 or NH3, it's gone to NO2. So it's gained oxygen, and then it's gone to NO3, so it's gained even more oxygen. So both these steps in nitrification are oxidation reactions. Now, if you're a chemist, you'll be able to see that the oxygen is in group 6, has a -2 charge. Overall, there's a minus charge. As it's 2 times -2 for the 2 oxygens, that's -4. That means that the oxidation state of nitrite is +3 with the nitrogen. If you apply the same rule to the nitrate and you go 3 times -2, because oxygen, when they form ions, when you work out their oxidation state, they take 2 electrons, so they're -2, they're -2. So 3 times -2 makes -6. This means if it has an overall charge of minus, the nitrogen must be +5 in that situation. And so if we look at the nitrogen atom, it's gone from +3 to +5. So in that movement, it's lost 2 electrons in that process. Anywho, that's longness. Right. Yeah, this is A2. It's done in Unit 5. Whatever it is. It's done in cycles, the unit where you do the phosphate cycle and stuff like that. After you've done MPP and all of that. So yeah, it's kind of in the ecology units in all the exam boards. But yeah, let's have a go at this question here. So this diagram shows part of the nitrogen cycle. You may have done it if you did triple at GCSE. You may have done the nitrogen cycle depending on what exam board you did, or if you did international GCSE. So you've got nitrogen going from the abiotic atmosphere being turned into ammonia, NH3, and it asks us what is process P and Q. And then you've got nitrates, which are the soluble form that plants want to suck up through their roots by active transport. But you've got some of those nitrates in the soil being returned to the atmosphere as nitrogen gas through process P. And this says name process P and Q. So what do you think process P and Q are? What's everyone studying at the moment? What you guys, Matilda, what are you studying at the moment in bio? What's going on in your bio lessons at the moment at college? What about you, Galafias? What are you studying at college at the moment? Any particular units you're working through? How you guys finding your A-level studies? Remember, you got to put in like a good 5 hours a week external on your each subject if you want to get the kind of tip top results. A levels are hard, but you just got to keep working. Are you doing photosynthesis? So the light dependent reaction, the light independent reaction, enzymes.
I can't handle the stress no more, dog. These damn A levels. I can't handle the stress no more, dog. These damn A levels.
Oh yeah, double bubble. Right. Yeah. So what you got? P is denitrification. Q is ammonification. Sounds good. Hold on. So P is definitely denitrification. 100% right. You might think that Q is ammonification, but they might also put nitrogen fixation, because you can make ammonia through the process of nitrogen fixation as well in the root nodules of the plants by rhizobium. Oh, you're starting immunity in bio. Yeah, students, out of the AS topics, the year 12 topics, students find immunity. They find the process of clonal selection and expansion really difficult. So they find the kind of like, yeah, They find that bit quite difficult. It's a lot to remember all the bits, but you can simplify the process. What you want to do is try and simplify all the content and the processes so they're just like revision card based. And then you can build around it. Because a lot of biology is application and stuff, so you want to simplify everything. Yeah, and you're doing photosynthesis, you're doing the light dependent. Yeah, that happens. Teachers do miss lessons. Yeah, totally. You did the nitrogen cycle at GCSE. Yep. Okay, let me zing. Um, this next question says it is estimated that each year a total of 3 times 10 to the 9, what's that, 3 billion, something like that, tons of ammonia are converted to nitrate. So they're saying that you've got 3 times 10 to the 9 of this ammonia, and they're saying that is converted to nitrate. Only 2 times 10 to the 8, so a smaller number, you've got a whole zero knocked off there, of ammonia are produced from nitrogen gas. So they're saying that they're saying made straight from the nitrogen, you're making 2 times 10 to the 8 is made from nitrogen gas during nitrogen fixation. So that's going to be nitrogen fixation, 2 times 10 to the 8. So what they're asking you is, oh, okay, so the reason that process Q in the exam, let me just the reason that process P is denitrification, that's only got one possible answer. Now, process Q, you might have thought, oh my days, oh, this is not good. Denitrification. So, reading this question carefully, this is the correct answer for P, denitrification. But when we look at Q, ammonification will not be accepted here. So at first I was thinking, oh yeah, the formation of ammonia is ammonification, and it can also be nitrogen fixation. But this is directly, Q is saying from nitrogen in the air to ammonia. That means that the only possible answer for process Q is nitrogen fixation. Ammonification, where we make NH3, ammonification is done by decay of organic matter. So just going back here to explain the difference, 2 processes form ammonia. One of the processes is ammonification, and we come from poo, feces, urine, dead organic matter. So it's not from nitrogen in the air, it's from a dead organism, so a living thing, something that was once living, being broken down by organisms called saprobionts. These are single-celled fungi and bacteria that specialize in feeding on dead things, and they're saprophytes. They feed on dead stuff and they turn it directly into ammonia. So that's like a biological process going on there. We've got this biological process where you've got inorganic nitrogen in the air being fixed, and that's process Q. So it's nitrogen fixation for that one. This one also makes ammonia, same product but slightly different process. Anywho, back to the question, because I get caught up wafflingo. This question here is saying, well, look, it's saying 2 times 10 to the 8 of ammonia are made from nitrogen fixation. So it's saying explain the difference in these figures. How can there be more ammonia than is made by nitrogen fixation? What was the other process we said that makes ammonia? So the other process we said, and we just looked at just now, that makes ammonia is ammonification. So we want to talk about ammonification, and that is involving death, decay. So nitrogen, I shouldn't do that, that's the total. But yeah, the rest of it, that minus that, so 3 times 10 to the 9 minus 2 times 10 to the 8 is made by ammonification. So the other process would be ammonification, and you just describe like ammonification also produces ammonia, and then we could say via saprobionts. You spell that like this: bionts via saprobionts, decay, decomposition, dead matter, dead organisms, waste. Yeah. The conversion of ammonia to nitrates, says here, involves oxidation. What is the evidence in the diagram for this? So we could talk about the fact that there's oxygen on there, right? That's evidence that it's oxidation. Oxygen atoms have joined to the nitrogen. Or we could say, if you knew about oxidation states, you could say the nitrogen's gone from +3 to +5, or it's become negatively, well, you wouldn't want to say it's become negatively charged. That wouldn't help. I would just stick, if I'm a biologist, to say the nitrogen has gained oxygen. So it has gained oxygen. So, and you could do that by saying it's gone from NH3 to NO3. So yeah, you got the required practical the mitosis route next Thursday. Nice. So you probably have to calculate mitotic index as well on that. So you got to remove the root cap. Don't smear the root cells. All of that business. Yeah, there's loads of bits and pieces on that. Let me give you. So I'll give you a little. Actually, I might have a little look on the physics and math tutor site for some. So if we look at this, freshwater marsh soils are normally waterlogged. This creates anaerobic conditions. Use your knowledge of the nitrogen cycle to suggest why these soils contain relatively high concentrations of ammonium compounds and low concentrations of nitrite and nitrate ions. So this is an AO2 topic. So when you learn the nitrogen cycle off by heart and you know all the steps off by heart, which you can just do from your revision guide, and that's the first step. You want to get a C grade in A-level biology, you need to learn the content off by heart, because then you're going to cover most of the AO1, which is 35 to 40% of your course. But the AO2, which is making up another 30% of your course, is the application of that knowledge. And so this is an application question. What they're saying here is the soil is filled with water. It creates anaerobic conditions, so there's no oxygen in the soil for the plants and the bacteria to access. Use your knowledge of the nitrogen cycle to suggest why these soils are high in ammonium compounds and low in nitrite and nitrate. So what do you think the answer would be to this? So if we go and look over at our diagram, it's saying that nitrogen fixation can still happen, or ammonification can still happen. So these processes, nitrogen fixation is mainly an aerobic process by azobacteria or rhizobium. By basically, most nitrogen fixing bacteria like to do aerobic respiration. There are some that can do anaerobic under low oxygen conditions, but most of those in the soil. So that's possibly not causing the massive high concentration of ammonia, but you're still going to get decay into ammonia. That can be anaerobic. But this process is nearly 100% aerobic, nitrification. So you do need to know that for your AO2. So any ammonia that is already in the soil, if you take away oxygen from the soil, i.e. flooded soil or waterlogged soil, no oxygen in the soil, these aerobic bacteria can't get the oxygen and they can't do oxidation, and so therefore you will not get a lot of nitrates. However, any nitrates that are already there will be depleted because denitrifying bacteria are anaerobic. So this is something we have to know as well. Denitrifying bacteria are anaerobic. They don't require oxygen, so they can take the nitrates that are in the soil that plants love and they can turn them into nitrogen. So what happens when it rains hard and you get a flood? This can mash up people's head, because they can think, well, why are the farmers complaining? Surely water is one of the key reactants in photosynthesis. Surely all that water is going to help their crops grow, whether it's trees, whether it's wheat, whatever it is, it's going to help their crops grow, right? And they're going to make loads of money. Like, why are they complaining? Actually, it does the reverse. The soil becomes infertile. And the reason is plants need nitrates, NO3, to make amino acids and protein and grow. And it's an aerobic process. So when it rains hard and the soil fills with water, there are no air pockets left. The water pushes the oxygen away and there's no oxygen left around the roots. The roots can't do aerobic respiration and absorb nitrate ions by active transport, but also the process of nitrification, turning ammonia into nitrates, the usable form of nitrogen that plants want, is prevented because that requires oxygen by the aerobic nitrosomonas bacteria and nitrobacter. So that's a really common theme in the nitrogen cycle, is that when it rains or in low oxygen conditions, what happens? And in low oxygen conditions, there will be a depletion of nitrates from the soil. So we need to know that, essentially. And there'll be lots of questions testing you on that. And why can denitrification still happen? Because these bad boy bacteria, the denitrifiers, the one that take nitrate ions and complete the nitrogen cycle and put nitrogen back in the air, they don't need oxygen. They like anoxic or anaerobic environments without oxygen. Most of these ones, nitrogen fixers, prefer aerobic conditions, and quite a lot of these prefer aerobic conditions when oxygen's available, but some ammonification can still go on. Some of them do anaerobic as well. But yeah. Okay. So essentially, that's what the answer... Oh, we didn't do this question. No, I'm just on a random question that we didn't do. We were on this one about the waterlogged soil. So explain why you would have high concentration of ammonia, because you still get decay and decomposition, but you won't get nitrification, and you won't get you will get denitrification, removing nitrates from the soil, but you won't get nitrification because they require oxygen for aerobic respiration. Let's see what the answer scheme says. So less nitrification because they require oxygen for aerobic conditions. Yeah. We could have also said that denitrification can continue, as those can do it in anaerobic. But here we go. Yeah, let's have a look at another question. Oh my days. Okay, describe the role of saprobionts in the nitrogen cycle. Saprobionts, they're normally single cell, but I found a picture of some mushrooms. Saprobionts in the nitrogen cycle, 2 marks. What do saprobionts do? So they're the ones that are going to get rid of dead things. So what keywords would you put up for how they get rid of dead things? What would be your key words? It's only a 2 marker. What do you think you need to say to score 2 points? So you should be able to say 2 separate points or 2 separate keywords to do with what happens to dead organisms or waste. So think about those keywords and what you'd use. If someone said you've got dead things and waste, and what's the role, what happens to them in the nitrogen cycle by these saprobionts that do saprophytic nutrition, basically they feed on dead things. What are they doing? What keywords would you use for that? So you probably want to say decomposition, decay, they're turned into ammonia or ammonium ions. The saprobionts turn organic matter into ammonium ions or ammonia in the process called ammonification. And then you could say decay, decomposition. So those would be the kind of keywords that should be popping in your head. So learn your AO1. So your revision card should be something like role of saprobionts, and then on the back, just keywords. Biology's a game, so your brain needs to be just hitting with mark scheme type keywords. It's all about the key terms. So if someone says ammonification, you'd have saprobionts, you'd have decay, decomposition, forming NH3, forming NH4+, which is ammonium ions. Those would all be there. Yeah, probably. So to be honest, I had a disaster this week, so I didn't really prepare properly for this live. But yeah, so they use enzymes, they decompose proteins, DNA, RNA, whatever, decay, decompose proteins, nitrogen-containing compounds. So we've got some named nitrogen-containing compounds producing ammonia, NH3, or ammonium ions. except they perform ammonification, except a name ammonium compound, you know, sodium, ammonium nitrate or whatever. Yeah. Producing, releasing ammonium, yeah, blah, 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 blah. So essentially, these guys do decay, decomposition, and they break down organic molecules into ammonia. And what they're getting you to do is acknowledge that those organic molecules they break down. Why can't you break down starch? Say I'm a dead plant. Why can't starch be turned into ammonia? Why can't lipids be turned into ammonia? So think about why is it that when you name an organic molecule, you're better off saying DNA or RNA or urea or protein. Why can't we say, oh, lipids and starch or glycogen? A dead human would have a lot of glycogen in their muscles. Why can't that glycogen be broken into ammonia or converted into ammonia? And the idea is it doesn't contain nitrogen atoms. So anything that has nitrogen atoms in it, like nucleotides, like ATP, like protein, amino acids, what they can be broken down during decay and they can form ammonia, which is NH3, or ammonium, which is NH4 plus ammonium ions. So yeah, that's their role. Their role is to get rid of organic matter. If it wasn't for the saprobionts in the nitrogen cycle, there'd be a lot of unused protein and there'd be a lot less nitrogen returning to the soil. So it's a cycle. So all of the things play vital roles. Farmers use artificial fertilizers to maintain or increase the yield from grain producing crop plants such as wheat. Artificial fertilizer is used to replace mineral ions removed from the land when the crops are harvested. One of the mineral ions is nitrate. Give two examples, here we go, of biological molecules. We've just seen them on the previous question. What biological molecules contain nitrogen? That's basically what they're saying here. This was an AO2 question. So your AO1 is, do you know what molecules contain nitrogen? And then your AO2 skill is being able to apply it. So this says, give two examples of biological molecules containing nitrogen that would be removed when a crop is harvested. So when I pull wheat or carrots or potatoes out the ground, what biological molecules could be in those carrots or potatoes that carry nitrogen? And so you'd be thinking of DNA, RNA, proteins, amino acids, those type of things. Anything that could potentially be containing nitrogen is what's getting removed when you pull it out of the ground. Anywho, yeah, it's the old nitrogen cycle. It's exciting times. Now, how do you guys revise when you have tests? How do you revise when you've got like a test coming up or something like that? So let me show you what I would bust out if I had a test coming up. Watching YouTube videos is good, but what you've got to make sure is, do you do exam questions when you go to, like, do you use physics and maths tutor? Do you know how to use physics and maths tutor and save my exams and all of that kind of stuff? Because you need to be able to use those guys as well. So let me just let's go and have a look at that. Okay, so there's lovely Google. We love Google. Okay, yeah, walkthroughs are good, but you've got to use everything. So like go PMT, AQA. If you're AQA, biology A level, just bash that in. First thing that comes up, AQA A level biology. Bash on that, and then you've got physics and maths tutor. Scroll down, and then you can just pick your revision topic, and you'll get all the exam questions coming up. So you could bust out over here and be like, this topic, the nitrogen cycle, comes in here. Yeah, practice questions are good. And then you can come down here and nutrient cycles. These are going to have, this is 2022 to 2024. Then you've got 2016 to 2021. And you've got all of these packs. Then you've got pre-2016 papers. These are good to use as well. Yeah, teaching your siblings is excellent, Matilda. If you've taught people a concept, then you can understand it. Look, I stole this question from pre 2016. So, and I say stole, I didn't steal, I borrowed, but you know what I'm saying. So, look, you can go through, you've got all these questions here. We've got another P and Q. Look at this question over here. It says, yeah. So this question, organic material, ammonium ions. So organic material, we're talking about animals, plants. They get turned into ammonium ions. And then we've got microorganisms and plants um, over there. Then we got nitrite ions, nitrate ions going back into the air as nitrogen, and ammonium ions becoming nitrite. What do you think P and Q are here? So what do you reckon P and Q are here? Now, when I do physics and maths tutor, what I do normally is I download this. There's a download symbol which my face is over. I download this to my desktop. So if I found a nice pack on nutrient cycles, I'll download this to my desktop. And then what I do is I'll download the mark scheme to my desktop, and I'll duplicate screen, and I'll shift one to one side on Windows and one to the other side. So I have the mark scheme and the test paper up. And then I'm just going to go through question by question, check the mark scheme, leave the mark scheme on the wrong question, you know, as you go down, and then scroll, have a go at it with a bit of paper, and then mark it. So that's the way to revise. So process P here, you'd be going from NH4 plus ammonium ions to nitrite. This would be called nitrification. And then this is also nitrification if that had a letter, and then this is denitrification, going back to nitrogen in the air. Now nitrogen going to microorganisms and plants, that's nitrogen fixation. They haven't put a letter on it. And that's really feeding. Here this would be organic material. This is animals eating plants, I guess. Oh, there it is, animals eating plants. And those plants and animals can die and become waste, or they can release feces, urine, and die, become waste. And then ammonification is there. But yeah, so these are really good to practice. Leguminous crop plants have nitrogen fixing bacteria. This one says here, let's zoom in a little bit. Leguminous crop plants have nitrogen fixing bacteria in nodules on their roots. Remember, I showed that picture of nodules with the little balls like on the roots of pea plants. If you like to eat dal or lentils or whatever, chickpeas, they're all from leguminous plants. They tend to be very high in protein. If you think baked beans, these are all, if you're vegetarian and you eat and you need to get a good source of protein, leguminous plants are great, and it's because they've got nitrogen fixing bacteria. So they're going to naturally have more access, or in the soil around them, to nitrates, which will enable them to make more amino acids than other plants, basically. So leguminous crop plants have nitrogen fixing bacteria in the nodules on their roots. On soils with a low concentration of nitrate ions, leguminous crops often grow better than others. Why? Well, this is because they have the ability to fix nitrogen into their roots via the nitrogen fixing bacteria that live in that mutualistic relationship. So we want to say the nitrogen fixing bacteria turn nitrogen into ammonia, and then it is turned into nitrites and nitrates by nitrification and can be absorbed. And this is called an AO2 question. So this question is quite difficult here. This is an AO2 question. This is saying, and what do we mean by AO2? This is an application question. So it's not straightforward. Applying high concentrations of, you kind of got a problem solve. Applying high concentrations of fertilizer to soil can reduce plant growth. So if you put too much fertilizer in the soil, it reduces plant growth. Use your knowledge of water potential to explain why. What key word do you think of if someone says water potential? What key word would you think of if someone says water potential? Hopefully you'd link water potential in your brain to osmosis, and then you go, all right, what's going to happen if there's a high concentration of something soluble like fertilizer, it's going to lower the water potential of the soil. Which way is the water going to move? From the soil to the roots or the roots to the soil? Well, obviously the plant is going to lose water because water will move by osmosis from a high water potential in the plant to a low water potential in the soil down a water potential gradient. And water is needed for photosynthesis. It's not going to produce as much glucose. It's not going to have as much do as much respiration, have as much ATP for growth and metabolism and those kind of things. So that's like an AO2 question where they get you to apply your knowledge. You need the knowledge, the AO1, but you've now got to figure out which bit you need to put down. Anyway, that's just showing you like Physics and Maths Tutors is a really good website. So I recommend duplicating the website, getting the mark scheme up, splitting the screen, putting half there, is what I do. There's lots of other websites that are good to use. Another thing, if you haven't got one, have you guys bought yourself a CGP? What I would recommend as well is that you guys get a CGP. So if I just bus on here and go CGP, obviously you can sign up. It's free to sign up to the CGP website. Now, I don't care who in the world is telling you their revision guide is perfect for A-level biology. There is no one that is consistently produces the same quality as CGP. So anyone selling you their special revision guide to pass A-level biology and they're charging you £50, £60 or whatever, that's a luxury. The first port of call is have a CGP. It's going to cost you a tenner online, and I don't get paid for advertising their products. I'm just telling you what I have, and you just like the beauty with the CGP, right? Is what you get with a CGP is, look, these are all my online products from the CGP. When you buy one from Amazon or wherever you buy a CGP book from, it'll have a code that lasts about 3 years, and this digital code on the front page, once you put it in, so don't get it secondhand off eBay because someone may have already used the code, then you don't get the online book. Now that you might not want the online book, but you can kind of download it on your phone and look at it on your phone. So like say you're doing Salters, I've got the AQA, I've got the OCR. So I've got AQA biology. If you're doing AQA, you click on that, open up the AQA if you're an AQAist, and bang, you can just flick through the pages. And I think for like a tenner or what this is going to cost you, this is like minimums. Like that's all the AS. This is really strips down the knowledge. Now I'm not saying would you get an A star just on the CGP alone. Yes, they say they've got 100% of the content. I would dispute that. I'd say they're the best revision guide in my opinion, but I wouldn't say they cover 100% of the content. There will be things missing in any revision guide because basically someone has streamlined down the content. There's always like 1 or 2% of knowledge. You're like, oh, they don't mention that in there. They should mention that, or they don't explain that. And like the same with A-level chemistry, I use the AQA CGP as my kind of like go-to book, but I would say there is like 5% missing from the specification. So, but I would still say it's still an easy way to learn 95%. So I would still go with this is my thing. So like if you're learning the nitrogen cycle, for instance, you just go here and bish bash bosh. I can zoom in and here we go. I've got my nitrogen cycle and I've got all the detail that you need to know about the nitrogen cycle in just like a little small thing. You can move that around. You can read all of that. I'm not saying the questions are the best in the world, but they're decent. The exam style questions, they're decent. They're okay. The main thing is that I can be on my laptop, can have this operating in the background. I can be on PMT on another tab. I can have the mark scheme up, doing a test. I can have the CGP. I get to a question now before going, oh, I can't do it. I'm going to the mark scheme. I can bust out my CGP on the tab and look it up and have a quick read because that's active revision, right? When people say, oh, how do you revise, sir? Well, that's how I revise. So if I'm doing questions on the nitrogen cycle, I have my nitrogen cycle content there. And then I get my question over here that might be on the nitrogen cycle. And rather than just straight away going, oh, I can't do it, I need to go to the mark scheme, I go, okay. Yeah, whatever. Look at this one. I use this one in today's lesson over here. Look, Fresh, this was the one about the waterlogged soil. This creates anaerobic conditions. Use your knowledge of the nitrogen cycle. Suggest why these soils contain relatively high. So I'd be like, oh, and then I'd go, okay, I'm stuck. I don't know what to put. So I'd go here and go, and I'd have a look and see if I can work out the answer from there. So I would have all of this open or when I'm revising on my laptop. And that way, yeah. I've actually got, Save My Exams has a benefit over PMT in that I have saved my exams, so I've got a login for that as well. You have to pay though for Save My Exams, I think. So I think I pay, I don't know how much I pay. Is it £10 a month or is it £10 a year? I don't know. I kind of forget about how much it is, but yeah, I pay a fee for Save My Exams. You pay like a yearly fee for access, but the beauty of Save My Exams is they don't have adverts. So when you go on to this, if you don't download it, you get some advert playing every 5 seconds on PMT. But one of the but very similar to Save My Exams, PMT. But remember that PMT has mind maps, so you can use their mind maps of nitrogen cycle and whatnot. I know I sound like an advert for PMT, but I can't remember my login. I can't remember my login for Save My Exams, but I do have one. I used to swear by Save My Exams, and I used to get really put off with PMT from the adverts. But what I realized with PMT is it's free. You don't have to pay, and you can download the PDFs to your desktop and use them there, and then you don't have the adverts. So yeah, and they got flashcards. I've never actually used these myself. Some people, I kind of feel like, so they've got their flashcards. I kind of feel like you could use these, and then they got the answers on the back. You could use these, but myself, I'd rather make my own. If I'm going to make flashcards, I'd rather go to here and I'd make up my own questions. I think it's active learning. It gets you to think more if you make them. So if I'm like, if I zoom in on something here and I'm like, okay, this says nitrogen fixation is when nitrogen gas in the atmosphere is turned into nitrogen containing compounds. I would have like a revision card, and on the one side I would have, what is nitrogen fixation? Question one. On the back I would have, it's when nitrogen gas is turned into nitrogen compounds like ammonia, NH3. And then I would have, and then you could have what bacteria carry it out, and then rhizobium. And then question three could be, where do nitrogen fixing bacteria live in leguminous plants? And the answer would be root nodules. So what type of relationship do nitrogen fixing bacteria and leguminous plants have? And then on the back, mutualistic. So that would be, I've gone through and I've had to dissect that paragraph and turn it into questions and answers. And now I can use it when I'm watching TV, watching Netflix. I can just have a whole one on the topic. I can have like 30 revision cards all on, not just the nitrogen cycle. Nitrogen cycle, you need like 4 or 5 cards. But on the whole of Unit 5, I could have like 30 cards and I can just sit there while I'm watching TV. But making the cards is even better revision, and then using them is pretty decent as well. And that will get that AO1 content drilled in. And for bio, if you want to get a C grade minimum, you need to know your AO1 off by heart, your content. And then if you want to get a B or A grade, then you've got to learn how to do the application questions. And then for AO3, you need to be able to do all those kind of evaluation questions and all of those as well, which I'm going to do once on. Again, Matilde, I would do revision cards. So I do revision cards. As boring as it is, eventually you will learn them. So I would have like, there is only like 10 different shapes, 10 different shapes, and you need to know the number of pairs of electrons and that kind of thing. So you would you would have something like, your question on the revision card would be, what is the shape of water? What is the bond angle? And then for your third bit, explain why it has this shape. So you would sort of say, for water, you would say it's bent or non-linear. And then you want to know what the bond angle is, 104, whatever it is. What is it? 104.5. And then you go explain why. And you say, all right, it has 2 lone pairs to minimize repulsion. they get as far apart as possible. But you also might want to go into more detail about how you came up, how you learned that it was bent. You'd have to do the whole thing where you work out how many electrons around the central atom and that. But making the revision cards will help with you being able to spot all the basic ones. Once you know all the basic ones, like when something has 4 pairs of electrons, and so another one you could do is, what is the shape of a molecule that has 4 pairs of electrons around the central atom and no lone pairs? That's tetrahedral. What is the shape of a molecule with 4 pairs of electrons and 1 lone pair? That's pyramidal. What is the shape of a molecule with 4 pairs of electrons and 2 lone pairs? And that's bent or non-linear. And so you just make your revision cards, you just drill it in, and after a while, once that's drilled in, you can move on to the next bit. Let me understand why that is. But you do have to do some basic donkey work with these things. You got to put in the there's no easy way. Remember, every time you're doing A levels and you think they're hard, remember what the A stands for. The A stands for advanced. So you are doing an advanced course that's respected around the world. It's respected for its academic difficulty. As much as people will tell you, oh, A levels are easy or whatever, they're respected. That's why the G in GCSE is for general. The A is for advanced. So it is advanced. So they want you to memorize all this stuff, and then for the top level people, they're saying take it a bit further. You can't get the top grade from memorizing. You have to be able to apply the knowledge. So they can tell you here, okay, nitrogen fixation is when ammonium ions in the soil are changed to nitrogen compounds, but that's just you learning that off by heart. But then you've got to learn to apply the knowledge. So denitrification, they tell you here that it's when, so you would have like a revision card, what is denitrification? And then on the back, you would put when nitrogen containing compounds like nitrates, NO3, are converted into nitrogen gas by denitrifying bacteria. And then you could have a question, what kind of conditions are needed for denitrification? It's normally under anaerobic conditions without oxygen. Now, if you've learned that off by heart, that's like C grade level, AO1 content level, and you need to learn that off by heart with revision cards. What is the AO2 application of that? They then tell you why is when the soil is waterlogged and filled with water and there's no oxygen in the soil, why is it that the nitrate concentration goes down? And so now you've got to go, oh, well, I remember that denitrification happens during anaerobic conditions. And so that would be applying your knowledge. You'd be, because denitrification is happening. NO3 is being turned into nitrogen. So you've learned it off by heart, but then you've got to learn the skills of how to apply it and when to put that knowledge in. That's what moves you up to B and A grade, and then the AO3 being able to do evaluations and things like that, and knowing, I need to put 3 advantages, 3 disadvantages, and write a kind of supporting statement or whatever. That's another skill as well. I'm going to do some lessons on that as well, like how to do all of that business as well. But yeah, so I highly recommend the CGP Save My Exams. Is very good. It's kind of like, yeah, it's very good. It's got videos, it's got loads of exams. They make their own questions as well, so you don't just have to use the exam questions. So it has loads of good things about Save My Exams as well. The only difference is you've got to pay for it, but then you don't get the adverts as well. So that's kind of a bonus. So it depends whether you're someone who's like, I don't mind paying the whatever. I don't know what the annual fee is now. £30. What are that man on Save My Exams asking now for a fee? How much is Save My Exams annual membership? I don't know what an annual, I've got it, but I don't know what it is. £48 a year. So it's £48 to get Save My Exams for the year. I would say physics and maths, if you're just looking for exam questions, gives you all the same things. You don't have to pay for it, and you don't have the adverts. But if you're like, no, I can't be dealing with the adverts, man, it's only £48 for my A level, I'm going to get Save My Exams, then yeah. So, you know what I mean? It all depends how you want to look at it, really. £48 isn't that bad in the grand scheme of things. But I'd definitely say get yourself a revision guide, so that when you're trying to learn stuff, you're not just going straight on to having to open your big fat class book every time when you want to learn something. Yeah, and then a lot of people in the chat, they say things like, what's that one? They say not sen. Oh, I can't even remember. The one beginning with S, people like. Anyway. Seneca. Yeah, Seneca. I haven't really used Seneca. I got the impression that Seneca is good for AO1 content learning. It's just like loads of multiple choice kind of questions. So that, again, I would use different things, but don't think any one thing is going to get you an A star. So if you just relied on the CGP alone and nothing else, not going to get you an A star. You want to broaden and use more than one thing. But I definitely, myself, I teach myself through like using the CGP and exam questions combined, like, and then I challenge myself like, nah, if I can't do a question, I'm like, nah, let me read the bit from the CGP first. If I'm like getting stuck on an exam question, I'm like, oh, I'm not really sure. I'll have a go, like bullet point. Then I'll go and read the CGP, the page on it, just that one page that covers that question. Then I'll have a go again, and then I'll check the mark scheme. And then once you've done that, you kind of know these are. Anytime someone says the nitrogen cycle, all of those keywords should be bumbling around in your head, and then it's just a case of spotting when it's time to use them. Anyway, that's the end. I know it's a bit of a major crusty like a croissant lesson today. So yeah, going to shoot off. Why's my screen black? I don't know. Okay, right. I'm going to see you lot later. So keep revising, keep working hard. I am going to release more papers in the coming weeks in the run up to Christmas. I'm going to release more papers and more walkthroughs and stuff like that. So yeah, just keep working hard, keep plugging away. Um, Another little tactic that I use. Where's my CGP? Let me show you one more tactic. Yeah. Oh, hold on. Yeah, that's CGP, whatever. What I was going to say, another tactic I would use is go to the front. I'll just, it's easier to show you on online. I was going to open the book. What am I going to do? Hold it up to the camera like a plum. I'm going to be off in 2 seconds. But what else I would say is a really good tactic to use. Say you got like your contents page on your CGP and you got like carbohydrates, right? So don't spend hours getting a calendar, putting it on your wall, color coding your revision when it comes to your mocks or when it comes to, don't do all that business, man. That's a lot. Just get your CGP. What, you paid a tenner for it, 11.95 off Amazon or something. Don't worry about it. At the end, you can dash it at the end of 2 years. It's £6 a year. That's cost you if you get the one that contains the whole A level in, right? So who cares? Don't what you can still sell it on eBay after and get £5 back if you really want. Now, what you can do, what I would do is when I've revised the topic, so if I'm revising now for my A levels, I'm going to be right today, Saturday, I'm revising carbohydrates. So what I'm going to do is I'm going to read the content in the CGP and I'm going to make up my own key, which I'm going to write up here. So R might be I have read. So I'm going to put a letter R and then I'll put a 1 next to it. Or I might put the date, March, April, whatever. So when did I revise it? So you're keeping a record. So I've read through. Then I would be like, have I done any exam questions on it? Now my code for that might be SE for save my exams, or PMT if I'm using that, PMT. And then I'll put a number like 1, so I've done it. So when I go back now, as I'm working through the year and I'm looking back, I'm keeping a record of what I've revised and what I haven't revised. And I don't know why this is barely on the screen, but should be over there. So, oh my gosh, what is that? Never mind. It's all going Pete Tong. Yeah, so I would be keeping a record of what I've revised. So when I look at this, it should be like R, like R, R. I've read all of the sections, R, 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 and I might have R1 and then like exam questions. I don't know, like I might put a Q, meaning I've done a question. And then basically I'll have a broad picture. Whenever I sit down on the weekend, I'm like, right, I feel stressed. I've not been doing my A-level biology. What am I going to do? And I open that contents page. I can be like, oh, well, I've done carbohydrates, lipids. I haven't done any I've read proteins, but I haven't done any exam questions on proteins yet. So you're keeping track of your overall map of where you are in the subject. You might be like, oh, sugar. I haven't done antibodies in medicine. I haven't looked at monoclonal antibodies and how they're used in medicine. I feel like I've revised the immune system loads, but I've got nothing next to this here in terms of every time I do an exam question on antibodies in medicine about monoclonal antibodies, I want to put a Q there so I can keep a track like, oh yeah, I've done 5 different questions in the last year on this. I ain't going to stress. So that's just one thing. Little tactics like that. Keep yourself revising, keep yourself focused so you know what you're doing. I would definitely put a tick next to it or some sort of symbol. Make a key up for red. Made notes. You might have an F for flashcards. Have I made flashcards on it? Have I done a mind map? Maybe have an M for mind map and a Q for question. So by the end of the course, you want to have, I've read everything. I've made flashcards on it. I've made a mind map and I've done exam questions and that kind of thing. So you can keep track and know which bits you're doing or not. Okay. Yeah, and you can space it so you can be like, you could put a date or something like that, or like how many questions you've done. So you could put Q1 and then the next time you do a question, you put Q2, next time Q3. And so you know, oh, I've done loads of questions on that. And there we go. Coolio. Anyway, I'm going to finish this. Loads of little tactics for revision, but just use active revision. Of course, by the time you get to the final exam, make sure you've done every past paper. That's the one thing. So again, how are you going to do that? Are you just going to wait till April of year 13 and then, or wait till March and then be like, oh, randomly I've done like a couple of past papers. You want to make sure you've done everyone and you note it. So you could write that here on your CGP, keep it all in one place. So you could be like 2018 paper 1 biology, tick, done with your score. Score yourself and put a score there. And then you could be like, so you keep track. So now when you open it, you know I've already done that paper. Like otherwise you're just coming back and randomly doing papers with no kind of structure to it. So that's what I would do. I'd keep track and I'd write it down, and then like I've worked through every paper, I've got my score. Maybe you do the same paper again and you write your score the second time you do it and things like that. If you do it a year later, the same paper. Anywho, keep track of it. Keep working hard, guys. A-levels is all about hard work. That's what most of A-level is. And A-level is also about consistency. So you're still working even when you're in those down periods where you feel like, oh, I can't be bothered. You're still putting some work in and keeping track of it. Right, guys, I'm going to shoot off. So take care and I will catch you next time. All right? All right. Time to finish. Oh, my gosh. Yeah, big a boom for those couple of people that showed up today. It was a bit of a crusty lesson, but there we go. Boom! And I am going to see you guys next Thursday. I will actually put some time in next Thursday to what I'm actually doing. All right, nice one. You guys have been amazing.